Good afternoon, good morning, good whatever it is to you. This is Stereo Police. I will be mounting this camera to a tripod, never fear. This is just temporary. Welcome to Lecture 1 at Audiophile University. Lecture 1 will be called or titled Charge and Current. And I want to say this is probably going to be my longest and most tedious lecture, but it's absolutely necessary because it's the foundation of everything. Everything. And you always need to establish a good foundation, to build everything on. And this is probably where a lot of the misunderstanding about electronics comes from. And so I promise you, if you bear with me through this and pay attention to everything, you're going to come out of this a whole lot more knowledgeable. And you're going to learn, unless you're already a physicist, but you're going to learn, if you're the average non-technical audiophile, you're going to learn a couple of things that are shocking. Pun intended. I'm going to start with a demonstration, but let me say this first. And again, I will be mounting this camera to a tripod, okay? So sorry if you're getting seasick. Electric current is not defined as the flow of electrons through a conductor. All right? It's not. After understanding this lecture, when you hear people say this, just smile to yourself. Just smile. Okay, in a circuit, electrons do migrate in a direction generally from negative to positive charge. But a baby can crawl faster than an individual electron migrates through the conductor. I'm going to draw a conductor here, and I'm going to draw a little electron, and then I'm going to put in an electromotive force here. And a lot of people believe that once you, I could have put a switch there to close it, but that once you apply an electromotive force across a conductor, that this little whole electron is going to travel in a straight line through the circuit from one point to the other at the speed of light. This electron might travel, 1 meter in an hour. Are you shocked? All right. Again, electric current is not defined as the flow of electrons through a conductor. That's why you're here. Let's talk about it. But first, I want to do a little demo. Okay. What you're looking at is just a piece of wood. It's a door jamb of my house. This right here I'll talk about later. That's a piece of parchment paper. That's an insulator. I've got 2 pieces of Scotch tape. I just peeled it off of a roll in my office. All right. What I'm going to do, I want to stick these pieces of tape onto the wood. quickly peel them off. Watch what happens. They don't like each other, do they? They're not happy with each other. That's called static electricity. Now, let me take those same two pieces of tape, and this time I'm going to put one of them on top of the other. Just like that. Okay, one on top of the other. I don't want them totally stuck together, so I can peel them off. Now they love each other. Now they're attracted. Okay, now that they're attracted to each other, I'm going to take one of them, put it on this side of the parchment paper. I'll stick it really good. Going to take the other one and put it right on top of that one on this side, on the opposite side of the parchment paper. And I could, if I wanted to, roll it up really tight. Really tight. This is a really bad roll, but let's say I rolled it up really tight. I've just created the capacitor. I'm storing electric charge. One plate is charged negatively, the other plate is charged positively. Static electricity.